Welcome back to part 3 on quadratic functions and graphs. We're going to look at a generic function this time, and we're going to derive the formula for the vertex. First, we group ax squared plus bx separate from c. Then we factor out the a. This gives us a times the quantity x squared plus b over ax, and then we need to find the third term in our quadratic and insert it and then subtract it on the outside. Remember, our formula for finding the value to insert as the third term is 1/2 of b quantity squared, which in our case is 1/2 of b over a quantity squared. This gives me b over 2a squared, and I'm left with b squared over 4a squared. That's what I will add as the third term. And if I look at that, I can check to see what I need to subtract from the outside. Since a is multiplied to all three terms, this number that I subtract on the outside needs to be the product of a and b squared over 4a squared. When I multiply those together, I will subtract b squared over 4a. I've kept my expression the same by adding and then subtracting the same value from the expression. We've just changed the form now. Now I will factor my perfect square trinomial that I just created. I'll get an x and an x. I will get a b over 2a and a b over 2a. Notice that the b over 2a is always the number inside this rule before I square it. This works every single time. So the b over 2a is very important to remember. That works every single time you do this. Getting a common denominator for our c on the outside, we're left with plus 4ac minus b squared all over 4a. I can rewrite my perfect square trinomial as a times x plus b over 2a quantity squared plus 4ac minus b squared all over 4a. So my vertex will always be the opposite of the number inside parentheses. So my vertex on this is going to be at negative b over 2a. That's my x coordinate. My y coordinate is negative b over 2a, whatever that comes out to be, inserted into my entire function for x. This will give me the output or y coordinate for my vertex. So the vertex of a quadratic function of the form f of x equals ax squared plus bx plus c is negative b over 2a, comma, f of negative b over 2a. If we want to graph the following quadratic function by writing it in standard form and finding the vertex as well, we can also determine the domain and range. And it's actually quite easy once you've put this in standard form. So the first function we have here is f of x equals x squared minus 2x plus 2. Grouping the first two terms gives me x squared minus 2x plus 2 on the outside. Now I need to take 1/2 of b and square it, which will give me my third term. That gives me -1 squared, which is 1. So I will add 1 on the inside of parentheses. If I add 1 on the inside, I have to subtract 1 on the outside to keep my expression balanced. Now I can factor x squared minus 2x plus 1. I know that factors to x minus 1 times x minus 1 plus 1 if we combine the terms on the outside. So -1 plus 2 is +1. Writing this in simplified form, I have x minus 1 squared plus 1. This is my function f of x in standard form. So if I find the vertex, it will be at 1, 1. I've shifted my function to the right 1 and up 1. Since there's no vertical or horizontal stretch, I have a parabola with the same standard proportions of a normal parabola x squared. Over 1 up 1, over 2 up 1, 2, 3, 4. So I just count from the vertex and I can create this function that has a parabolic shape to it. Since the leading coefficient is 1 and it is positive, I know that my function is opening upwards. Whenever you have a positive leading coefficient, you know that you will have a minimum value for your parabola. So this function has a minimum, and the minimum is at 1, 1. So whenever your leading coefficient is positive, your function has a minimum. If your function has a leading coefficient that is negative, your parabola or function will have a maximum because it will flip the parabola so it is opening downward. Let's list the domain of this function. The domain of this function, since it's a parabola, there are no radicals and there are no variables in your denominator because there's no fractions. So this domain is -infinity to infinity. The range of this function is from the minimum, because remember, range is how far up or down the Cartesian plane the graph exists. So this would be a minimum at 1, so we include 1, and it continues up toward positive infinity forever, so this range is from 1 to infinity. Notice that this parabola does not cross the x-axis. So this function does not have x values or solutions for x other than imaginary ones. However, it does have a y-intercept. We can find the y-intercept by substituting 0 in for x, because anywhere along the y-axis, x is 0. This will give us 0 squared minus 2 times 0 plus 2. So our f of 0 equals 2. Our y-intercept is at 2.